So here is our warm-up for today. Determine the degree and type of polynomial. Let's start with number 1, and I'm going to start by determining the type of polynomial. So here we don't have any plus or minus signs. Everything's put together by multiplication. So this is a monomial. Now to figure out the degree of the monomial, remember degree only deals with exponents of variables, not numbers, so the 5 we just ignore. This y has an invisible exponent of 1, so we go to plus 1, which tells us this is a degree of 3. Since it's a monomial, there's no other degree to compare it to, so we call it a third degree monomial, or you could also call it a cubic. Number 2, we don't have a monomial here because we've got a plus sign, which means I've got one term, two terms. If I have two terms, we call that a binomial. And now I have to figure out the degree of the binomial. Well, the first term has a degree of 2 because it's just an x squared. The second term has 2 exponents, so we have to add those together. 3 plus 2 is 5. So we compare the 2 degrees, and since 5 is bigger, this is a 5th degree binomial. 5th degree does have a special name, if you remember that. That is the quintic. So you also could have called it a quintic binomial. Again, this workbook just deals with the number, but those are some good vocab words to remember for the degrees. Looking at your homework from last night, so hopefully you have it out. 11, 12, 13, not 13, sorry, 11 and 12. Maybe you called that a quadratic degree instead of second degree. And number 12, you might have called that a cubic degree instead of third degree, and that's fine. 15 through 20 is really just combining like terms. Be careful on number 20. You had to distribute that 3p, which went back to the last module. And you'll see I got the 6p cubed, the 6p squared q, and the 12p when I distributed that 3p to all 3 of those terms. Make sure you pause this until you've checked all of your answers. Scrolling it up, 21 was substituting in. They gave you 2 expressions, and the first one you were plugging in the 1 at 20 degrees, and the other one was 1 at 30 degrees. So 30 degrees would be greater because -6 is greater than -7. And part B said, how would they compare in size? There'd be more cells at 30 degrees because 66 is bigger than 56 again. Moving on. Number 23, you were comparing the polynomials and which one would have a greater value at 8. And that was the first one, the one that I've circled there, because its value was 310 instead of the 274. Number 27, the error was the correct degree was 3. You don't multiply degrees, you add them, but you can only add them within the same term. So there wouldn't be any addition here because this has a degree of 3, this one has a degree of 2, this one has a degree of 1, and since they're all separated, you don't add those exponents together. When you're done checking, you need to turn in the workbook to section 14.2. Today we're going to focus on adding and subtracting polynomials. To be honest, we've pretty much have done this a couple different times. We're going to be looking at combining like terms, but we have more terms that we have to combine here. And then subtracting them, we do have to work on that. That's the one that students make the most mistakes on, and we don't want to make those. So our first activity talks about 2 properties that we learned back in elementary school. Commutative property says you can take 2 things when adding and flip them. So in their example, 5x plus 4 is the same thing as 4 plus 5x. They flip the two numbers. Or negative 2 plus 6x is the same thing as 6x plus negative 2. The second property, the associative property, doesn't change the order, it changes the grouping. So here they had the second two things in parentheses, but I can't actually add 7 plus 2x. So if I change the order and group the 3 and 7 together, I could go ahead and simplify it. Same thing with the second example. They group these two together first, but there's no like terms there. But if they group the second two together, there are like terms there. So commutative, you actually see the numbers change positions. Associative, you see the parentheses move. So it says to identify the property used to change the expression each step. So go ahead and try to figure out which properties for A and B, and also answer the reflection question number 1. And then unpause this when you're ready to check how you did. So our first part A, the step changed the order of the terms. It was 8 plus 15x, and then they changed it to 15x plus 8. So they changed the order. When the order is changed, that means that was the commutative property. The second part changed the grouping. They changed where the parentheses were. And when you change the grouping, that's the associative property. And then they were able to combine the like terms. Again, we've talked about these properties before. We talked about how we really do this step in our head, where we flip them in order to put the like terms side by side. Part B, they ended up grouping it first, because the parentheses were around 4h plus 30 and 8 plus 6h. And then in the second line, they were around the 30 plus 8. So that's the associative property. And then they put the 30 plus 8 first and put the 4h plus 6h, so they changed the order, which is the commutative property. In the reflection question, it said, why isn't there a commutative property for subtraction? Hopefully you all figured out that if I subtract two numbers and then I flip them, I don't get the same answer. So for example, if I have 2 minus 3, which is negative 1, and I flip those two numbers to put it as 3 minus 2, I get a positive 1. So 2 minus 3 does not equal 3 minus 2. Addition, but not subtraction. So the first concept we're going to work on is adding polynomials, and again, this truly is simply finding your like terms. There are two ways that you could do it. You could rewrite it vertically, which is what they did here, so they lined up all of the like terms, or you could leave it horizontally and simply look for all of your like terms. Now mentally you're changing the order every time, the commutative property, in order to put the like terms side by side. We don't actually have to show that step. We also do it with using different colors or different shapes to mark our like terms. So we're going to go ahead and practice a couple together. So 3, 4, 5, and 6. We're going to do 3 and 4 together and then leave you to do 5 and 6. So number 3, I'm going to, since there's a plus sign, and inside each parenthesis are no like terms, we can go ahead and combine these and pretend the parentheses aren't there. So here I have a negative 7x squared. Remember, to be like terms, not only do the variables have to be the same, but so do their exponents. Well, that works out in this case. So I have negative 7 plus negative 1x squared. So that's negative 8x squared. If it helps you, especially when they get bigger, you can cross them out so you don't try to reuse them. Now the only thing left in that problem is that plus 3. So I'm just going to bring that down. And there's my answer. Again, really and truly concepts that we've talked about already this year. Moving over to number 4, same type of problem, just bigger. The biggest thing to notice is that A, there's no like terms inside each parenthesis itself, and there is a plus sign in between them. Minus signs are going to be what we talk about next. So I'm just looking for like terms. So I'm going to circle this 5x squared and look for any other x squareds. Here's one at the beginning. So 5x squared plus 1x squared, that's 6x squared. And they're gone. Now I have just an x. So I'm looking for any other x's without exponents, which here's one. So I have negative 2 plus 1. So that's a negative 1x, which is just negative x. If you want to put that 1 there, you can. So those are gone. And then I have a number all by itself. Here's a number all by itself, and 3 plus 2 is 5. So 6x squared minus x plus 5 is the correct answer. Go ahead and do 5 and 6 on your own. Check with a neighbor as you need to, and then unpause this video when you're ready to check your answers. Number 5, your like terms were the negative 6x squared and the positive 3x squared. That gives you negative 3x squared. Remember, whenever you're adding or subtracting, we do not change exponents. Exponents stay the same. So those are used up. And all that's left in that problem was the positive 5x. And there's my answer. Technically, you could flip this order and write 5x minus 3x squared, which would be fine. But we tend to write the highest exponent first. Number 6, first thing I ran into was an x squared. However, there's no other x squared, so it just comes down. Then there was a negative x and a positive 6x, so that makes a positive 5x, negative 1 plus 6, and then negative 1 and a negative 3, add those together makes negative 4. So hopefully you did pretty well in these two problems. Well, if we add, we also have to subtract. Subtracting is always changed to an addition problem if you really think about it. And we use it as add the opposite. So if I look at A, I don't want to say I'm subtracting because what happens is I remember to subtract the first number, but then I forget to subtract a negative 6n or a negative 8. So we don't want to make that mistake. So what we do is we add the opposite, which is really like the distributive property. So I change this minus to a plus, which means everything in the second parenthesis has to change signs. So the 2n squared becomes a negative 2n squared, the minus 6n becomes a plus, and the positive 8 now becomes a minus 8. And now I can combine my like terms just like I did in the last examples. Okay, and we'll actually combine them in just a minute. So part B, let's go ahead and go through that. So minus sign in the middle means we change it to the addition, and we change all the signs in the second parenthesis, the one that follows it. So this becomes a positive 6b squared, a negative 2, and a positive b cubed. And then I go through and look for my like terms to see which ones I can combine together now. So now we're going to actually practice the complete process together. So we're going to do number 10 together and let you do the next two on your own. So number 10, there's a minus sign in the middle, so we change it to a positive. And then since the 5m squared n was positive, it becomes negative. This minus sign goes to a positive, and that 7mn squared goes to a negative. So now we look for like terms. First thing I run into is an m cubed. So I'm looking for any other m cubes. Ooh, there's one in the same parentheses. And there's now a positive 1 here. So I have 4 plus 6 plus 1. So that's going to make 11 m cubed. And then I'm going to cross them out so I don't try to reuse them. Now I see a negative 1 m squared n. So I'm only looking for other m squared n's. So here's one. This one's not because the square is with the n and not the m. So I have -1 and a -5. So that makes -6 m squared n. I'm going to go ahead and cross them out. And then the only thing that's left is actually that -7 mn squared. I don't want to write plus negative because when it's plus negative, we just want to write minus 7mn squared. And there's my answer. So again, if you change it at the beginning, then it's just like the problems we were doing earlier. So go ahead and try 11 and 12. Check with the neighbor as you go through it, and then unpause the video when you're ready to check the completed answers. Here we go on number 11. First thing I'm going to do is go through and change the signs. And now we look for like terms. So I have a 2x cubed y. And you should have found the 3x cubed y at the end. 2 plus 3 is 5. Cross them out because I used them. Now I have a -6y. And then another -6y. So that's going to make -12y. Cross them out, they're gone. I have a 7x cubed, and now a -2x cubed. So that makes a positive 5x cubed. Now, if you're enjoying the colored part of this, but you don't have colors, well, you could do shapes. So you could do one set as squares, one set as triangles, one set as circles. So that works as well. 13. So plus, negative, and plus. Just making sure all signs become the opposite in the second parenthesis. So I first see a 3x squared. Here's another x squared. 3 plus 2 is 5. Then I have a positive 6x cubed, and now I have a negative 8x cubed. So that's going to make a negative 2x cubed. Then I see a number of -7 here, and I have a -5 here, so that makes -12. And then at the very end, I see a positive 4x, nothing else with it, so I'm going to bring that down. Now if you left that in this order, that's fine, not a problem at all. You also might have written it with your highest exponent first, which would be the 3. So then it'd be -2x cubed plus 5x squared since it's positive plus 4x minus 12. This is what we call the preferred way to write it. This is in standard form, highest exponent to lowest, but it doesn't tell you to do that, so the first answer is absolutely fine. The last thing we need to talk about are when we put them into word problems. So we have the cost of producing X toothbrushes, 400,000 plus 3X, and the revenue, because profit is the revenue minus the cost. So they took the revenue and they subtracted the cost of making them. That's your profit. We generally want that to add in positives, but it doesn't always happen in business. And then we had to add the opposite of the second parenthesis and then combine any like terms. So then they took this expression and they replaced the X with 200,000 to see what that profit would be. And the profit was 1.4 million for those toothbrushes. So 13 is asking us to take the same profit line, but this time to replace it with 10,000. So go ahead and do that, and remember you are using this line right here. And then unpause the video when you're ready to check. So you should have -0.00004 times 10,000 squared plus 17 times 10,000 minus 400,000. So we have to do exponents first. So we have 10,000 squared, which is 100 million. I'm going to go ahead and do the 17 times 10,000, which is 170,000. And then minus your 400,000. So now we have negative 0.00004 times 100 million, which is negative 4,000. Put these all together. And the company would actually lose, because it's a negative number, $234,000. So while it looked like it was great, if you sold 200,000, even if you sold 10,000, you're not in the clear yet. You have to sell more to make it worthwhile. Last problem here, so let's go ahead and do this one together. So we have the profit of the North Dakota factory is n squared minus 15n plus 23. And the Florida profit is n squared minus 20n minus 14. And it says to write a polynomial that represents the difference in profits. So we're going to take North Dakota, since it comes first, minus Florida. So that's n squared minus 15n plus 23. And we have to subtract from it the Florida's quantity, n squared minus 20n minus 14. So we're going to be doing add the opposite here. So plus, negative, plus, and plus. So we combine our like terms. N squared and a negative n squared will actually cancel, so they're gone. Negative 15n plus 20n makes 5n. And then I've got a positive 23 and a positive 14. Put those together, makes 37. And then you could, if you knew how many goods were being produced, you could replace that in for n. Much simpler expression to work with. Now 15 says not the difference, but the total. Well, total means we would add them together, so it's going to be ND plus Florida's profit. So we have n squared minus 15n plus 23 plus, and with the plus we don't really need parentheses unless it makes you feel better. They're really more important when it comes to subtraction. So now we're looking for like terms. So I have n squared plus 1n squared, so that's 2n squared. I've got a negative 15n and a negative 20n, so that's negative 35n. And then 23 and negative 14 makes a positive 9. And there's the total profit of the 2 plants. Tomorrow you're going to be practicing skills from 14.1 and 14.2 just to make sure we have the adding and subtracting down before we move on to multiplying.